Have you ever just looked at your pet or maybe an animal you see outside and wondered, what's really going on in there? It's one of those huge, fascinating questions, right? Well, today we're going to dive into the science that's actually trying to find an answer. So let's start with the big one. Are animals conscious? It seems like a simple enough question, but the answer is incredibly complex. For centuries, this was pretty much just a topic for philosophers to debate. But now, neuroscientists are jumping into the ring with some amazing tools to tackle it head on. And this, right here, gets to the absolute heart of the challenge. We can't just ask a bird what it feels like to soar on the wind. We can't ask a dog to describe the world it experiences through smell. We have no direct line into their subjective, private world, and that's been the biggest roadblock. So, how in the world do you get around that? Well, the strategy, which is pretty brilliant, is to start with the one mind we can study, our own. The idea is, if we can find the precise electrical signatures of experience happening in a human brain, we can create a kind of blueprint, a map to go looking for in other animals. Okay, so the source material makes a really critical distinction here, starting with this word, awareness. Think of this as the raw, immediate sensation. It's that simple, subjective, what it's like to experience something. The pure feeling of seeing the color red or hearing a note. In the brain, this is a pretty localized event, happening right in the sensory areas. Then you have consciousness. This is the next step. It's not just seeing red, it's what your brain does with that information. It's interpreting that red as, say, a stoplight, deciding to hit the brakes and getting your foot ready to move. This isn't local at all. It's a much more global event that recruits networks all across the brain. So let's just lay it out side by side, because this distinction is the key to everything. Awareness is the first step, that what it's like moment, a local flicker of brain activity. Consciousness is the second step, the what to do about it phase, which involves this big, global wave of brain activity. This two-step process is our roadmap. So if these really are two distinct moments in the brain, can we actually see them? Can we find their electrical fingerprints? You bet. Let's look at how scientists actually pinpointed them. They use this incredible technique called event-related potentials, or ERPs. It essentially lets them watch brainwaves happen in real time with millisecond precision. And by doing this, they can isolate the exact electrical patterns, these neural correlates of consciousness that pop up only when a person reports having a subjective experience. And this timeline is just fascinating. It maps out the whole journey. A flash of light happens, and for almost 200 milliseconds, that's nearly a fifth of a second, your brain is processing it, but you are completely in the dark. Then, boom, right around 200 to 250 milliseconds, this specific brainwave called the awareness negativity appears. That's it. That's the moment of awareness. Only after that does this later, much bigger wave called the P300 fire up. That's consciousness kicking into gear. So what we're left with are two very clear, very distinct signatures to hunt for. We have an early local marker for raw awareness, and we have a later global marker for conscious processing. These are our fingerprints. All right, now for the really exciting part. We've got our human blueprint. We know what to look for. So now we can scan the rest of the animal kingdom and see if any other brains show these same telltale signs of experience. And the findings are just, wow. They're stunning. In crows, researchers found that the neurons linked to subjective experience fired off about 225 milliseconds after the crow saw something. That timing, it's a near-perfect match for the human awareness marker. And this pattern holds up, even in brains that are wildly different from ours. Take dolphins. A key brainwave they measured peaked at about 200 milliseconds after a dolphin heard a sound. Again, that lines up beautifully with the signature of human awareness. And get this, in rats, scientists found the whole two-step sequence. They found an early electrical wave around 150 milliseconds that signaled awareness of a heat stimulus, and then it was followed by a separate later wave around 280 milliseconds, which corresponded to the rat consciously perceiving it and deciding what to do. So when you put it all together, the evidence we have so far is really promising. It strongly suggests that mammals and birds share these same neural markers for both awareness and consciousness. Now, for other groups like fish, cephalopods, or insects, it says inconclusive. But that's key. It doesn't mean they don't have it. It just means the jury is still out, mostly because the right kind of research just hasn't been done yet. Okay, so this leads us to the big why question.
If an animal can get by perfectly fine on just instinct and reflexes, why would evolution go to all the trouble of developing something so complex, so demanding as consciousness? What's it even for?
Because, and this is kind of wild to think about, a huge chunk of sophisticated behavior doesn't need it at all. Everything from reflexes to habits, even to some complex forms of learning, all of that can happen entirely on autopilot, with zero subjective experience required.
And here's the kicker. Consciousness isn't just complex, it is incredibly expensive. The brain is already an energy hog, but generating those synchronized brain waves that are linked to conscious experience, that consumes a massive amount of power. And evolution is famously cheap. It wouldn't pay that high a price without a really, really good reason.
So what's the reason? Well, this quote from the research literature nails it. Consciousness isn't for running the daily automated programs. Its evolutionary job is to guide behavior when an animal faces a new situation, a new problem, and has to choose what to do from a bunch of different options. This idea is a total game changer. It means consciousness isn't some constant state that's always on. It's an option. It's a special, energy-guzzling tool that the brain can decide to switch on when it runs into a problem that instinct and habit just can't solve.
Which leaves us with a final, and honestly, a much more profound question. We're moving beyond simply asking if animals are conscious. The new question is, if consciousness is a strategic choice, a tool to be deployed only when needed, when and why do animals choose to turn it on? Answering that, well, that's the whole new frontier in understanding the incredible minds all around us.